Today we're going to take a look at scatter plots. Remember that scatter plots have lots of dots. When we look at scatter plots, we need to think about independent versus dependent variables. Our independent variables are the x parts of our coordinate. So that's our independent variable. We also have dependent variables. That's the y. It's important for us to understand the difference between the two of these because it helps us make sure that we have plotted our scatter plot correctly based on which labels or which numbers we use on each set of axes. And so when we have a table of values, always the one on the left is your independent variable and always the one on the right is your dependent variable. Okay. So our y depends on the x. The amount of sugar in your coffee in relation to this situation here is determined potentially by how old you are. So the older you are, the less sugar that you need in your coffee or tea, whatever it is that you're drinking, because your palate has changed. Okay, so what do we need to know? Well, if I was to plot these coordinates on this grid, I would want to make sure that I represent the age along that x-axis here. So this is my age. So I always want to label my axes. I already have the scale listed for you. So every square is going to be 5. So this is the age. And the age is in years. So sometimes it's helpful to express what it is that you are measuring that particular thing in. And then along the side is my y value, and this y value represents how much sugar we include in our beverage. And in this case, the sugar we're measuring that in teaspoons. Okay. So now that we have our axes labeled, now we can start to plot our points. Remember that we always go left or right first before we go up or down. So my first point is going to be 7 and 1.2. Now I'm going to have to just sort of guess where 7 might be because I am not going over by ones for my age. I know this is 5 and this is 10, so 7 is probably somewhere in between, a little bit closer to 5 than it is to 10. If I look at the scale on my y-axis, I can see that this is going up by 0.1. 0.1, 0.2, 0.3, 0.4, 0.5, which is labeled, 0.6, 0.7, and so on. So I know that I can find 7 along the bottom, and I'm going to go up to 1.2. Here's 1, 1.1, 1.2. There's my first dot. Then I'm going to go over to 15. That's going to be right in between, right on a line, and up to 1. There's my second dot. I'm going to continue this pattern for all of my points in my table of values. So over to 35, up to 0.3. Over to 18, approximately where that is, and up to 0.6. Again, over to 18, and I missed the one above that, so 18 and up to 0.8. Over to 29, so just below 30, and up to 0.6. Over to 44, so just below 45, and up to 0.7. Over to 53, and 0. So I'm not going to go up at all. So I'm going to stay right on that x-axis where I think 43 might be. So maybe about here-ish. And 51, and I'm going up to 0.5. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay. So I know that I plotted those correctly. All right. I also want to give this a title. Every good graph needs a title. So I might call this the amount of sugar people put in their cups. Okay. So we've created that scatter plot. Okay. I can see from the pattern of the dots that it looks like that as we are, as someone gets older, so as they increase in age, it looks like they are going to decrease the amount of sugar that they put in their cup. So that's interesting for me to note. Okay, so that's the relationship between those two variables. So age is variable 1 and sugar is variable 2. So that's the relationship between here, okay? And maybe I'll put that down here at the bottom. So the relationship would be as a person ages, the amount of sugar in their cup decreases. Now, I can easily see this rather than looking at the dots by drawing something called our line of best fit or a trend line. I like to call it a line of best fit. That's what we're going to call it, but you might have heard it called a trend line. So how do I draw that trend line? Well, I want to draw that trend line or the line of best fit by using a ruler. So I want to use a ruler to draw the trend line or the line of best fit. That's what goes here, the line of best fit. So that it overlays the graph. So I want to put it on top of my dots, and I want to try to get the same number of dots or the same number of points on one side of my line as I do on the other side of the line. And sometimes it's easier than other times. Okay, so I want the same number of points above the line as I have below the line, and if I can go through some points, that's even better. Okay, and we always want to make sure that we use a ruler so that it is a little bit more accurate. So if I was to follow or draw my trend line, I might draw my line so it's about maybe here-ish. So that seems to follow the path of my pink dots that I have. Okay. All right. I can't forget that one down there. So again, the trend line or the line of best fit also helps me determine the relationship between those two variables. As a person ages, the amount of sugar in their cup decreases. We can now see that clearly using our line of best fit. The line of best fit helps us determine the type of correlation that a scatter plot has. So a scatter plot, as we can see in our graph right here, could have a negative correlation. That means as one variable increases, the other decreases. So our example here has a negative correlation. Our line of best fit is going down from left to right. We could also have a positive correlation. That's when our line of best fit would go up from left to right. And sometimes our dots are all over the place and we can't clearly tell what the relationship is between those. So we might say that that has no correlation. So if we can't see a pattern in our dots, it would have no correlation. We can also have a strong correlation or a weak correlation as well. The closer the dots are to the line of best fit, the stronger the correlation. The further away they are from that line of best fit, the weaker the correlation. And we'll take a look at that in more detail in another day. So let's analyze some examples. What type of correlation do we see in the graph above? Well, we could see that we have a negative correlation. That was clear from our line of best fit. We can use that line of best fit to determine what a potential point might be that maybe we don't have in our table of values, but we can estimate based on our line of best fit. So this says, which would be most likely for a 38-year-old to have? 0.2 teaspoons of sugar, 0.5 teaspoons of sugar, or 1.1 teaspoon of sugar. So we're going to come back up to our graph, and we're going to find our line of best fit for someone who is 38 years old. So 38 years old is approximately right here. And I'm going to follow the 38 all the way up until I reach my line of best fit, about right there. And so I would estimate that someone who is 38 years old would probably have about 0.5 teaspoons, because if I follow this along to my sugar scale, it's about 0.5. It's a little bit higher, but it's closer to 0.5 than it is to 0.2 or to 1.1. So I can use that line of best fit to predict what someone might have that is not given to us in that table of values. So down here, I would say 0.5 teaspoons. Now, we were able to find that information from our line of best fit, and we're going to talk about something called interpolation versus extrapolation again later on in this week. All right. Now let's take a look at number 3. Number 3 says, what type of correlation would you expect between these two variables, and explain why? And here are the two variables. X is the number of minutes taken to deliver pizza, and Y would be the number of stars given for customer service rating. Now, I don't know about you, but I prefer my pizza hot and steaming right from the oven. The cheese is nice and melted, it's ooey gooey, it's great, okay? And I'm not a huge fan of cold pizza, but I know some people are. So I would argue that this would have a negative correlation. So the longer it takes for someone to deliver your pizza, the lower the ratings you might give them, because you have to wait longer, so you're probably going to be hangry, and it's going to be colder, so it might not taste as good. So I would say that this would have a negative correlation. And someone could argue this the opposite way, and I look forward to some of those discussions when I get back. So it's a negative correlation, so NEG for short. And why is that? What's the reason of that? Well, I'm going to say that because as time waiting for the delivery as it increases, so the longer you have to wait, satisfaction will decrease. So your satisfaction level decreases. Let's explore some more analysis for scatter plots. Let's take a look at this scatter plot that's given to us that represents shoe size versus height. Now, this is something that forensic analysis might do if they are trying to figure out who maybe committed a crime, right? So they take a look at maybe the imprint of someone's shoe and they use that to determine the person's height. And we can see from this graph, if I was to draw a line of best fit through this data, it goes up from left to right. So we have a positive correlation. I can also see that my dots are very close to my line of best fit. So this would be a strong positive correlation. So what does the question say? The points on the scatter plot are trending upwards to the right. Yeah, that's true. They totally do. Taller people will usually have a larger shoe size. We can see as the height increases, the shoe size also increases. Yeah, that's true. That makes sense according to our graph. This scatter plot could be used to predict someone's shoe size if you know their height. If I know someone's height, I could take a look. If I don't have numbers, but if I knew someone was this tall, I could go up to my line of best fit and I could go over to the shoe size scale and I could determine how tall they would be, or vice versa. If I know someone's shoe size, I can go up to where it would be on that shoe size scale, go over to my line of best fit, and then back down again to find their height. So yes, it goes both ways. So this would also be true. Let's take a look at the next example. We have exam scores versus the number of missed classes. So let's draw our line of best fit on this graph. Now this is pretty straight, isn't it? So it's going to be easier for me to draw my line of best fit. There's not my line of best fit. It's going down from left to right, so we say this has a negative correlation. And again, those dots are pretty close to my line of best fit, so this would be a strong negative correlation. Question number 1 says the points on the scatter plot are trending downwards to the left. Well, no, they're not going towards the left, they're going towards the right. So this would be false, and I have to be sure of what that is actually telling me, right? So sometimes highlighting, right, key things in that question will help you determine that. Right? If I went up, I saw that this was upwards to the right, which matches that. So I would hope that this would also be downwards to the right, but it says downwards to the left. As I go left, it's actually going up, so this one is false. Number 2, people who miss more classes will score higher on the exam. So if I find maybe someone who, again, it's increasing as it goes up that x-axis. So maybe someone who misses a lot of classes would be at this point right here. I'm going to go up to where my line of best fit is. There's that point, and I'm going to go over to where my exam scores are. Now that's not that high, is it? So people who miss more classes would probably get a lower score on the exam rather than a higher score. So this would also be false. This scatter plot could be used to predict the number of classes someone has missed if you know their exam score. Sure. So if I know someone's exam score is, if this is 20, 40, 60, 80, 100, right? So it goes up by 20. Let's say I know someone has a score of 60%. So then I would find their 60% and I would come over here until I reach my line of best fit, and then I would go down to where I think the number of missed classes would be. So maybe these are, I don't know what the scale might be here. Maybe this was like 1 and then 3, 5, so maybe this is about 4 classes. Or it could be going up by 2s. We don't know what the scale is. But yeah, we could, if we know someone's exam score, we could go follow over to the line of best fit and then come down and make a prediction about the number of classes that they missed. So this is true. Last question. Average house prices along the side, that's our independent variable, right? This is independent variable. This is our, other way around, my apologies. This is your dependent variable. This is your independent variable. All right, average house prices versus age of house. So as the house gets older, what does that mean to the average house price? Now, when we look here at this slew of dots on this grid, it's hard to tell whether the dots are going up, whether they're going down, whether they're going straight across horizontally. They're all over the place. So this would be an example of no correlation. It's hard for us to determine whether the points are going up or down or, something else in between. So this is no correlation. The points on the plot are nonlinear. So do they follow a straight line? No, they don't. So this would be true. Number 2, the age of a house determines how valuable it is on the market. Well, because we have no correlation, we can't draw in a line of best fit, which means that we can't use that line of best fit to help us predict the answer to certain questions. So does the age of a house affect how much it's going to sell for? No. Sometimes if we look here, if a house is, again, I don't know what the scale is, but let's say a house is 10 years old, right? If I come up here, I don't really know for sure if it's going to sell for a little bit or if it's going to sell for a lot, right? So I can't determine that. So the age of a house determines how valuable it is on the market. No, I'm going to say false. Number 3, this scatter plot could be used to predict the price of a house if you know how old it is. Again, we can't determine that. So it would be false as well. Because there's no correlation, there's no information that I can glean from this scatter plot to state an opinion one way or the other. You're going to use the information that we shared here for scatter plots. Hopefully you've had some practice in elementary school drawing scatter plots and investigating two variable data. So you're going to use the information today to take a look at some questions on your own, sketching a scatter plot and analyzing some data.